morning. Welcome to Relief Tutorials classes. In the last lecture, we have seen about image formation by concave mirror. We could not cover the whole topic of image formation by a convex mirror. So let's repeat it. Image formation by convex mirror. You know the convex mirror, which has outer surface reflecting and inner surface colored. This is imaginary principal axis. Here is pole, center of curvature, and principal focus. In the first case, we are placing the object at the infinite distance, and we know that the rays coming from the infinite distance are parallel to each other. So these are the two incident rays parallel to each other, and as per the rule that these rays are virtually passing from principal focus. They are virtually passing from principal focus. So here is the virtual point of intersection of these two reflected rays. So here the image is obtained. Position of object was is this kind of table we have formed. The first case, position of object is at infinite distance. Position of image is at F behind the mirror. Nature is virtual and direct, and size of image is point-like. This was the first case. Second and the only case for convex mirror is you are placing the object between infinity to pole anywhere. Between infinity to pole anywhere if you are placing the object. Consider here we are placing the object. This is the object between infinity to pole. So if you place the object here, then the first ray goes like this according to rules. The first ray goes parallel to principal axis and reflects like this, virtually passing from principal focus. You can use the second rule that if the incident ray goes virtually from F, it will reflect parallel. Or you can use the third and the easiest rule that if the incident ray goes directly from C, it will reflect in the same direction. So let us say this is the third rule ray, that this is the incident ray going from C. So incident ray passing from center of curvature, so it will reflect in the opposite direction like this. So you can see two reflected rays. These are the two reflected rays which are divergent. They are going away from each other. So this is the point of intersection of the extended rays which are extended behind mirror. So this is the point of intersection, and this point of intersection is virtual. So here the virtual image is obtained behind the mirror. So the position of image, we can say it is between P and F. What was the first case? In the first case we have placed the object at the infinite distance. You can compare like this, the position of object was at the infinite distance. You are bringing it closer. If you are placing the object at the infinite distance, the image is at F. You are taking the object nearer, image also coming nearer. You can see the image coming nearer towards the pole. So if you are placing the object more nearer, the image is still coming nearer. So in the whole case, what is the conclusion? The conclusion is, in the convex mirror, the image always lies between F and P. Image never goes beyond F. Image remains between F and P. wherever you are placing the object in front of convex mirror from infinity to O, the image always obtained between P and F. This is a very important point to note. So position of image is between F and P. Nature is fixed as virtual and direct, and size is always smaller than the object. The size of image always, see some fixed things to remember in the case of convex. The size of image is always smaller than the object. The nature of image is always virtual and direct. Position of image is always between F and P or at F. Fixed things. No varieties of image found by the convex mirror. One of the use here for this convex mirror is what it is used in rear view mirror in vehicles. See, normally we experience this, that we have rear view mirrors in our two-wheelers and four-wheelers. So we can see the vehicles coming behind us. The nature of that image will be virtual and direct. So we can see inside the mirror, we can see the image behind the mirror, and the size of that will be what? Smaller than the object. So there is only one use of convex mirror, that is used in rear view mirror in the one of the use of that. It's very important. So this is all about the image formation by concave mirrors and convex mirror. These are the very important points to remember, because the next part of this chapter is all based on all these cases of concave as well as convex mirror. So please make a note of it. Now the next topic is about how to measure the distances. See, consider here is one of the concave mirror. This is principal axis, here is pole, here is center of curvature, principal focus, which is exactly in between C and B. Let us say this is one of the object. So we can see the object is beyond C. Object is beyond C, so the image will be between C and F. I am not drawing the rays, just I am drawing the image. Let us say this is one of the image. This is the image of this object. Object is beyond C, so image will be between C and F. Size of that image will be smaller than the object. Nature real and equal. Now in this figure, let us say this is x, y, name of this. So this can be said as x dash, y dash. This is pole. Now in this figure, how many distances are important? See, the distance between C and P, already we know it is called as radius of curvature. Distance between F and P is called as focal length, the most important characteristics of every mirror. Here is the object. Now distance from pole to Y, means Y point is the bottom point of object. So I think this distance is called as distance of object from the mirror. Distance between pole and the bottom point of this object, this distance is called as object distance, and object distance is symbolized as U. Now this is the point of image. So this distance can be said as distance of image from the mirror, and that is symbolized as V. So there are four important distances to be measured in the case of spherical mirrors. Four distances. U means object distance, means distance of object from mirror. V, image distance, means distance of image from the mirror. R, radius of curvature, distance P to C. Small f, focal length, distance P to F. So these are the four important distances. But the question is, Look at it. In this case, object is in front of mirror obviously. Image is also in front of mirror. We know one of the case of concave mirror that if you place the object between F and P, so the image will be behind the mirror, means on the virtual side. So here all the distances, see, P to C means radius of curvature, P to F means focal length, let us say this is xy, so P to Y means object distance. All these distances you are measuring on the left hand side, but this, let us say this is x dash y dash, so P to Y dash distance you are measuring on the right hand side. Object distance means P to Y, image distance means P to Y dash. Here object distance P to Y left hand side, image distance P to Y dash left hand side. Here one is on the left, one is on the right. So some distance sometimes are on left and some are on the right. So we have to measure the distances according to some particular sign conventions. If you are taking this left hand side distance as negative, then the right hand side distance should be taken as positive. Or if you are taking the left hand side distance as positive, then right hand side should be negative. So we should have some particular sign conventions. Means sign convention means logic is what? That all the distances should be given as some particular signs. The distance should be either positive or negative, because the distance here we are measuring are some on the left and sometimes on the right. Look at that in the convex mirror. Let us say this is convex. This is principal axis, pole, focus point and center of curvature. Here you are placing the object here, so we know that the image will be here like this. Now look at this. This is xy. So P to x distance means object distance, left hand side. This is x dash y dash. P to y dash on the right hand side. P to f right hand side. P to c right hand side. Here all these are on the negative side, means left hand side, and here all these are on the positive side. So in which case you are going to take this P to C or P to F or P to X distance negative or sometimes positive. So we have some particular sign, we have some particular rules. Conventions means some fixed rules are there so that we can assign the proper sign to the distances. So the topic is Cartesian sign conventions. Cartesian sign conventions are for what? So these Cartesian sign conventions to measure distances for mirrors. Cartesian sign conventions are for what? For measuring the distances in the mirrors. We have four distances to measure: object distance, image distance, radius of curvature and focal length. So which distance should be negative and which distance are positive? We have some fixed rules. The first rule and the most important rule, look at here, either in the convex or concave. This is convex mirror and this is convex concave mirror. Whatever the mirror you are having, pole is the origin. Pole is the origin. All the distances you have to start measuring from pole. You have to consider that you are standing on the pole, and then you decide that in which direction you are going to measure the distances. Just like this is concave mirror, so this is center of curvature, this is principal focus. So if someone asks you to measure the radius of curvature, So radius of curvature means P to C distance. Here in the convex mirror, this is F and this is C. So here is P to C. So when you start to measure the distance, you stand on the pole. You consider yourself standing on the pole. So from pole you are going on this side, and here you are from pole you are going on this side. You can see that both are opposite. So one of them should be positive, one of them should be negative. So which one is positive and which one is negative? For that, the rule number one. That rule number one is all the distances always measured from pole on principal axis. The distance should be always on principal axis, means straight distance you have to measure, and always measured from pole. Second rule, listen to me carefully. From pole, distance measured in the direction of incident ray. From pole, distance measured in the direction of incident ray. Listen, this is concave mirror. Where you are going to place the object? In front of it, maybe here or here or here or at the infrared distance, wherever. Consider you are placing the object here. So in which direction the incident ray goes? So I think this is the direction of incident ray. Can you see that? Here is the object. So obviously, to form the image, we are going to incident the ray in this way only. So this direction is taken as positive. From pole, distance measured in the direction of incident ray is taken as positive. This distance, if you are going in the direction, means look at this, in this figure, right hand side direction is taken as positive. Here you are going to place the object here on this side because this is the reflecting surface. So in which direction the incident ray goes? It goes like this. Okay. So distance in this way means right hand side is taken as positive. Now here, when you start to measure the radius of curvature, you have to go from P to C. So can you see you are going from P to C, means in this direction you are going to measure the distance. So that distance should be taken as what? Positive. But here you are going from P to C. In the concave mirror, you are going from P to C in this way. Can you see it is opposite to incident ray? So if you are measuring any distance, first of all you make it clear that you are standing on pole. And from pole you decide that in which direction you are going. So if you are going from pole to P to C or P to F or anyone, so if you are going in the direction opposite to incident ray, taken as negative. And in the direction of incident ray, taken as positive. So rule number 2, from pole, distance measured in the direction of incident ray is taken as positive, and opposite to incident ray is taken negative. So if you are going in the direction of incident ray, those distances are taken as positive, and if you are going opposite to incident ray from pole, those distances are taken as negative. Let us take some examples. Consider here is the object. This is concave mirror. Here is pole. Here is F, and here is C. So if you place the object here, this is X, Y. Obviously the object is here, so incident ray goes like this. So these directions are taken as positive and opposite directions are taken as negative. Now if you start to measure all the distances, all these 4 distances, first of all radius of curvature. So radius of curvature means P to C. So can we see that we are going from P to C? P to C means this direction, and this direction is taken as what? Negative, because it is opposite to incident ray. So can I say radius of curvature P to C should be taken as negative, means minus R. Practically, if it is 10, then it should be minus 10, like this. Now the second distance, focal length. Focal length means P to F. You are standing on pole P to F. P to F means you are again going in the negative direction. So that focal length also should be taken as negative. Means if it is 5, then it should be minus 5, like this. Now object distance. Object distance means P to Y. Object distance means P to Y. Again you are going P to Y means this opposite to incident ray. So Py distance is object distance, and that should be also taken as negative U. Image will be obviously formed here like this. Consider it is x dash, y dash. So the object image distance is Py dash, and that should be taken as minus B. Here. Let us say in the convex case, let us take some examples only. These are some examples only. This is P, F, and C. If I say this is the object, so I think the image will be here in between P and F. X, Y, X dash, Y dash. Now again start measuring all the distances. First of all, the radius of curvature P to C. Can you see that P to C means you are going in this direction? And here is the object, so incident ray goes like this. So these directions are taken as positive, and these directions are taken as negative. So P to C means radius of curvature. You are going like this, and like this means it is positive. So PC is positive R. Can you see Py is also positive focal length? Py dash, the image distance, also positive, and Py object distance is negative. Here focal length P to F. Py means object distance, and that should be negative because it is going like this opposite to incident ray, and Py dash, it is going again in the positive side, so it is plus V. So in this way we can allot the signs to the distances. It depends on every figure. So these are only two examples here. But first of all, whenever you are thinking about the signs, how to provide the sign, how to allot the signs to the distances, you have to think about this rule. First of all, you think that in which direction the incident ray goes. Second thing, you take yourself standing on the pole. From pole, you are going in which direction. Then only you can allot the proper sign to the distances. One more rule. See, this is concave here. Here is the object. So this is xy, object. What is the height of object? This may be object, and sometimes the image is inverted like this. X dash, Y dash. Okay. So this is the height of object, and this is the height of image. But we can see that the object is on the upward side and image is on the downward side. So one of the height should be taken as positive and one of them should be taken as negative. So the perfect rule or the fixed rule is, if you are measuring the height upwards distances or upward heights are taken as positive and downward heights are taken as negative. So the rule number 3. Heights measured upwards are positive and downwards are negative. So these are the 3 rules to measure the distances in the case of mirrors. We can draw the aggregate figure for that. Consider This is the reference mirror we are taking, principal axis. This is P, C and F. Obviously we can place the object here in front of that. So these distances which are in the direction of incident ray are taken as positive, and distances opposite to incident ray are taken as negative. Upward heights are positive and downward heights are negative. The only fundamental is this. See, in the next lecture we are going to derive the very important formula which is very famous as mirror formula. For GSEB, means Gujarat Board students, mirror formula can be asked in your board examination. For CBSE students, the derivation of that formula never asked. But the problems are very important. So in the next lecture we are going to derive the mirror formula. But for that you prepare yourself for all those 6 cases of concave mirror, 2 cases for convex mirror, and the most important, Cartesian sign conventions. So please, before entering in the next lecture, first of all you prepare yourself that you should know everything about the image formation by concave, convex and the Cartesian sign conventions. Then only you can refer the next lecture. So please be careful, prepare the notes for these, prepare yourself, and then only you enter the next lecture. Best of luck.